Wow, they want to advertise. Okay, I don't know. Alright, so what is happening here? Let's see. Wow, okay. Meanwhile, Twitch already made a lot of progress. Or at least they have a lot of stuff returning. So theta is not a rational angle most of the time, right? Okay, yeah. So like does z squared just work? For what is my board doing? Oh my god. Okay, let's try that again. So if I'm thinking like if s is equal to z squared. So let's look. Thank you, Headrecker, for the follow. So if like s is equal to r equals 1, theta is 90 degrees. Then you can take like s is equal to z squared, and this is good. So r equals 1 satisfies, at least. Or plus minus 1 for that matter satisfies. Okay, should be the same for a 60 degree, right? If I take s equals like, wait, sorry, I meant doesn't satisfy, because it does not satisfy. So r equals plus 1 fair. Whereas if I take, similarly if I take r equals like plus minus a half. So like theta is 60 degrees or 120 degrees or things like this. Wait, is cosine 60 is 1/2, right? Then you can take s equals hexagonal lattice. And it is not true that the midpoint of any 2 points in S is also in S. So r equals plus minus 1/2 should both fail. Okay, so Those are the edge cases though. Most cases are not like this because cosine, oh, sorry. Cosine of 90 degrees is 0, not 1. So this should say 0. But I guess r equals plus minus 1 are vacuous. So r equals 0, r equals 1, r equals plus minus half all fail, but for silly reasons because those are the only cases where theta... Yeah, so can S just be a set of finitely many points? The answer is usually no. But the theorem that you're thinking about is, there's a theorem that's called Niven's theorem, which says that if theta is a rational multiple of pi, then cos theta is irrational unless it equals 0 plus minus half or 1. So almost all of the time, Chebyshev, yeah. I mean, this is sort of a very classical result. There are... So what that means is that if I have a set S with greater than 1 point, then there's automatically, for almost all cases, there's automatically like a bunch of cases, or a bunch of points. So if I have 1 point and like another point, except for these special cases of R I found, there will usually be like something like that, where the angle is irrational. And so you can get like a dense subset of a circle automatically. Yeah, so mostly theta is not a rational multiple of pi. And so good sets, for all but these stupid sets, sorry, what am I missing? For all the non-silly, other than these 5 special cases, you will get you will always get a countable dense subset of every circle, and now all heck is going to break loose. So I just have a really hard time imagining a good set that isn't the whole plane. It will be dense in the plane. Actually, I believe that. If you don't get the whole plane, then contradiction. No, I disagree that you get the... Actually, I disagree you get the whole plane. And the reason is that if you can define a set as follows. You let S2 consists of 2 points. And you can let Si be all points you can achieve by rotations of things in Si minus 1. So you start with 2 points, you add in all the points you need to, then you add in all the points you need to, all points achieved, and so on. And finally, so you let S be the union across all SIs. And if you do this, this will be a countable, each SI is finite. So we get a countable set S, good set S. So it is not true that the only good sets are the entire plane. Yeah, some people are already unhappy. Yeah. Yeah. So basically what this means is that you hope that... Is it true that every irrational multiple of pi is reached? I don't think so. Anyways, what I was going to say is that... yeah, we're not going to be able to describe all good sets. We need to actually think about... Actually, I feel like I will be surprised if I can give any description of a good set explicitly. Which bothers me because... Like, for values of R other than these how am I going to... Like, I'm trying to think how I'm going to possibly get a counterexample other than these. Like, these failed because I could explicitly construct a good set because it wasn't that bad. But I feel like I'm worried that for the other values of R, I won't be able to describe the set, which bothers me. Unless, okay, so oh frick, I missed. Thank you, I am an actual B hat for the follow. I think my stylus ran out of battery. Oh man, not prepared for the stream. No, it's not out of battery. What? Why won't it work? Okay. Here's the thought. Yeah. I had the same thought just now. I feel like I can give an explicit description where if crap, no, but the cosines won't be rational, right? Or the sign. So if I have like 0, 0, and A comma B, then the rotation is like, let's say R equals 3/5, okay? I want to pay attention to this one because something interesting I think is happening here. And suppose I start with 0, 0 and 1, 0. In fact, I'm going to follow the construction that I gave before. Then in general, okay, actually, bleh. So this goes to like 3/5 A plus 4/5 B, or something like that. 4/5 B minus 3/5 A. Scroll down, right? Yeah, so denominators like look like powers of 5, whatever that means. And so in particular, if I call this, if I follow the procedure that I described, you get a countable good set S that I a moment ago said was just terrible. Why not 1, 0? Oh, because in a moment I'm going to need to generalize slightly. But if I start with 0, 0, 1, 0, then I get a countable set S, countably finite set S, but it has the following property. Claim, first of all, S is a subset of the rational squared because of the way I designed it. And second of all, also denominators, I'll put it this way. V2 of, for every x comma y in S, the V2 of the x will be non-negative. There's no way I can get a denominator of 2 throughout this process. Countably infinite, yeah. A and B are integers, rationals. So the point is, by induction at every step, like I'm getting the new points by applying some matrix. So I'll get some rational things, and yeah. A and B are ints. No. So A and B, I initially have 0, 0 and 1, 0, alright? So I just have those 2 points, and then I start doing the operation and generating more things. And every time I'm doing a multiplication by this R, whatever this parameter R is. And some manipulation happens, but the point is the whole time, all the numbers are contained inside Q squared. And in fact, not only are they contained inside q squared, I'll say S is contained inside like the subset of q squared for which v2 of q is non-negative. Which is really good, because it means that... Okay. So r equals 3/5 also fails. Yeah, that's what I want. Okay, r equals 3/5 fails because of this rational number argument. Oh, jeez. So where is this going? This will work for any other Pythagorean triple. That is correct. For every Pythagorean triple, the answer is likely 0, right? Yeah, I had the same thought where I think I want to move into... I think it should work for non-Pythagorean triples, but I think I also... 3/4 works. Yeah, I bet it has to do with the parity of the denominator. I suspect that's what's going to end up happening. I have to say, I am surprised this did something. I was just like trying to convince myself that they were good sets that weren't just the whole plane, but okay, so more generally, okay, let's first start with the case where R has some... I'll be very concrete. Let's say like R is equal to like 1/3. So this is cos theta. So like sine theta was like 2√2/3. So because I'm doing manipulations like this, it seems equally implausible to me that you would ever get an even denominator. Like, no, right? You're not gonna get an even denominator. Like, who are you kidding? And so to formalize this, I just say start 0, 0, 1, 1. Thank you, YFX Kelly, for the follow. And then all coordinates always in... So now I need to specify, there's something here, but it's like Q... There is a notation for this. I really don't want to use it because it's too advanced. What happens if the denominator is even? The answer probably changes. Oh, actually, it's the same ring A for all of them. That's the ugliest math BBQ I've written in a long time. Okay, so there you go. Does abstract algebra ever appear on Olympiads? So the answer is on... First of all, it depends on what you mean by appear. If you define it as like is required for the problem, the answer is almost never, because that's not great. But it does occasionally help with certain problems. It will usually not help in a super deep way, depending on context. If it does help in a strong way, it's very often like algebraic number theory type things, I would say. I think if you... Maybe I'll put it this way. If you want to see applications of higher math on Olympiad problems, you should look at the napkin and you should look for the chapters on analysis, algebraic number theory, and linear algebra are the big ones where you will actually manage to get either non-trivial results or at least non-trivial intuition. Why does 3/5 fail? So the way 3/5 fail is for r equals 3/5, 3/5 a plus 4/5 b. Yeah. So when I use this construction that I described here, let me just say S0 is 2 points. In fact, I'll just call them 0, 0, and 1, 1, 0. Then when I do the rotations, okay, cool. At least 0? Yes, that's the point. Okay, so someone was saying something about 2 times a quarter equals 1/2, therefore 3/4 works. I don't see what that means. Yeah, I'm actually scared of the other direction. I suspect the answer, because this obstruction goes away, I suspect the answer is that the property holds, but I don't see exactly why. I wish this thing had one more color. Yeah, so I agree that we should, based on what we've seen, it's sufficient to consider, in some sense, this thing is the smallest non-trivial good set, so it makes sense that we're looking at it. That's sort of all we need to consider, actually. Like, if the property is true for the smallest one, it will work, and if the property is false... Yeah. We agree that we can increase the x-coordinate by 2r or 2r squared minus 1. What do you mean by... I'm a little confused. What are you trying to do? If r is 3/4, okay, let's specialize the r equals 3/4. So then 0, 0, 3/4 y. Okay, so... And then you can get minus 1/4 y. Okay, so... Okay, it sounds like geo. So you start from here, and then you rotate once, and then you rotate again. And then you rotate again. Something like that. Okay, so... Let me put these in a different color. You're right, this actually looks pretty good. So when you compute this, this was r, this was... So this is x coordinate like... So rotate, rotate, rotate. Why did you only rotate around the current pivot? For which part? How long does a question like this usually take? If you check my stream, you'll see that my solve times are all over the place. We also don't necessarily solve every problem. Like about half the streams there will be a problem that I just outright like give up on because I'm not getting anywhere. I feel like this one I feel like I'm going to eventually get because I have an idea where I'm trying to go. Jadon. Like freaking... Okay, anyways. Yeah, so hang on. I'm bad at geo. This is not 1 minus r, right? Like this is r. And oh, it is 1 minus r. Wait, I'm confused. Help, how did you... Wait, what? No. Is it 1 minus r? Are you sure? Yeah, because it doesn't look like 1 minus r. I bet all even denominators work. I just can't prove it. And we have an idea of proof, which is to use this diagram. However, because I am bad at geometry, I apparently can't figure out what the x-coordinate of P4 is. Wait, why is it 1 minus r? Okay, like this segment here. So this is R. Yeah, okay, let me work this out carefully. Because if I mess up this calculation, I'm gonna not get a correct solution. Restart. We are doing elementary geometry, all right? We are smart high school level Olympiad students. We can solve basic geometry. Okay, and we're told that this angle is equal to this angle, is equal to this angle. This diagram's off. So anyways, oh my god. So this is an isosceles trapezoid, right? And we're told that this distance here is r. This distance is 1. This distance is r. By symmetry, this distance is also r. So I believe this distance should be 2r minus 1. I think that's good. No, wait, what am I talking about? No. It's I drew the bracket in the wrong place. Yeah, 2r minus 1, right? Oh, so r equals 3/4 is a really great example because it gets us the midpoint right away. Yeah, so I like the Chebyshev approach. Thank you, some boost for the follow. So if I have 2r minus 1, so that means on this axis I can can I get any linear combination though? Like I feel like, can I get like 4r minus 2? We are smart high school. That's going in the quote log. Okay. Anyways, which means it's time to move on to another strat. I mean, I just don't, but here's the thing, I just don't believe that if like r is even denominator, like, I don't believe for a moment that like it won't, that like for no other even denominator r will you get a midpoint. Like there's gotta be a bunch of them you can get this way. Yeah, and in particular, yeah, like we could also, if I use like, this is also possible, right? If I do the double angle formula or like the triple angle formula. It also, this feels like it explains to me why R really has to be rational. Thank you, Soldier Man, for the follow. Did I see my stuff about 4n minus 1 over 4n? Wait, how did you get that? 7/8. Oh, okay, now I'm confused. What happens if what happens with 7/8? Like if I r equals 7/8, then I can get 3/4. No. Yeah, you get r equals 3/4. I think the reason I'm concerned is because it's what our construction is doing is it's saying that if I have like a segment, I can get this in a certain ratio. So it's a multiplicative argument, not an additive argument. It's not literally true that I can like get, say, I don't know. I can do this where it's like a geometric series towards there, and no, wait, I don't see how 7/8 works. Every x coin is divisible by 1 minus r. Yeah, I'm really... Is it not just 2 times a quarter? I don't understand. Like, it's... this isn't additive. Like, you don't... It's not adding. Like, you... Oh, wait, it is adding. Okay, okay, okay. I think that means I need a 5th point in this picture, right? So to label the order of the points that we're getting, 0, 1, 2, 3, 4, and then what you do is I add a last point that's called 5. Okay, I understand. You are adding. Okay, so that's fine. So for everyone else, because I finally figured out what was going on. The idea is that if I start with these 2 points, 0 and 1, then by doing this operation, I can get another pair of points which are unit distance apart. And everything is just shifted by a total of whatever this is. This is 2 times 1 minus r. Okay, never mind, we can add! Hey! Alright, cool. So you can add by 2 times 1 minus r, which does very little of r equals 1/2, but otherwise is pretty good. But by the same token, I should be able to add by... Okay, so if I can add by 2 1 minus r, so I can take the interval and shift it 2 times 1 minus r. Then I can also do the same thing with 2 times 2r squared minus 1 because of the double cosine formula. And if I can do that, then this is equal to 2 times 2 minus 2r squared. Okay, so I see where the... I see why people are concerned about 1 minus r. Yeah, Tournament of Towns is after this. Yeah, r equals 1 should always be a root, because it amounts to doing nothing. Oh no. I see. Okay, I see what you're getting at. Okay, so let's go a different... Oh my god, this is very scary now. I might actually believe you about the r minus 1 thing momentarily. Let me humor this line of thought. So let's suppose r is equal to like a over b. And then so like root 1 minus r squared is like root m over b. And the idea is if you're multiplying by stuff, and what I want to try and do is find a mod for which r equals 1. And this is possible if So if I'm looking at literally this fraction, then what I do is I look at divisors of b minus a. Take a prime p, divides b minus a, p doesn't divide a or b. Now this square root m might screw everything up. Unless m is a quadratic residue. Evan, will you be annoyed if I don't do my weekly Otis unit? No, I probably won't notice. I'm sorry, there's like 160 of you. I can't keep track of like how often people submit. Does this make any sense? Wait, okay, now I'm very confused. Does it make sense to take mod b minus a? Is this something I can do? Is this legal? I'm not even sure anymore. It should be, because whenever 2b squared minus a squareds collide, it will vanish mod b minus a. Thinking. Check if b minus a is positive. Is it not? How about I do r greater than 0 first, okay? Well, let's just do that case first. Greater than 0. So I think I can do this. I think I can literally take mod p. And well, the claim is that if I have 2 point, like every coordinate that shows up will be of the form like q plus like some rational number and then some other rational number times root b squared minus a squared. And the claim is that q mod b minus a makes sense, which it will because no bad denominators show up, and is always equal to 1. Or 0. Wait, hang on. No, this doesn't make any sense. What? B minus a is... No. What is going on? So what was our obstruction here? We had 1 minus r's. Is the 1 minus r really that much of an obstruction? I feel confused because it's like this distance here is divisible by 1 minus r. It doesn't tell you anything about this distance or something, right? Like somehow I don't feel like we should be having this problem or something. I don't know. What am I trying to get at? Thank you, Brian ZJK, for the cheer and for 10,000 bits. Hey. Which one is it? Yeah, appreciate the 10,000 bits. I was going to take mod P, but I don't think it's going to work. 10,000 bits is indeed a lot. I'm kind of confused. Don't worry, I am too. What just happened? The frick is this? Thank you, a noob, for the 1-bit cheer with 4 zeros after it. Okay, here's the thing though. Yeah, I think this B minus A thing is not going anywhere. But, so I built a trapezoid by going left. Can I go right as well? Like, can I? Thank you, Associate Heart, for 1 bit. So, like, okay, let me label the order of the points. 0, 1, 2, 3. Wait, what am I talking about? Hang on. No, that's not how it works. That's not how it works. Try again. What happens if I rotate the other way? Is what I'm trying to do. I don't think this works. Does that end up? Oh, is it just a rectangle? Right, okay, this angle is... No, it's not. What? No, it's not a rectangle. It's an isosceles trapezoid, that part I agree. So it ended up like here. Okay, basic geometry. Let's try that again. Maybe I should have used GeoGebra for this problem after all, huh? So, 1, 1, 1, 1. Okay. Oh no, but then I can't transfer, because I don't... Yeah, because I really feel like... I don't know, I feel like I got scammed or something. Like, Like, right now the obstruction to me winning is that this 1 minus r factor keeps appearing. And I feel like it shouldn't be there. Like, it doesn't feel like that should be a very big obstruction. Why not work with 1 minus r instead? How do you work with 1 minus r? Is it like... What? Okay, actually, here. Back in this picture, okay? Like, I can shift the interval... Wait, I'm so confused. Don't I have implicit ones because of the endpoints? Like, can't I say, like... You can shift the interval... by... I can shift the intervals left and right by 1 minus r, right? But I have a 0 and 1. Hang on, I'm so confused. Can I complex bash on arbitrary points in the set and use rotation matrix? Does that do anything? Like, I feel like the complex numbers don't give me anything that the matrix doesn't already give me. One minus r is strong in some way. Something about that just doesn't sit right with me. Like, I think I can show 1/4 does not work. Okay, never mind. Maybe it is that. Wait, no. 1/4 is. Doesn't 1/4 literally work using the picture that's on the screen? Like, if I plug in r equals 1/4, I get minus a half. Which just means I need to do the construction in a mirrored way, right? Or, no. Wait, it means I can go here. I'm so confused. What is going on? You start with 1, 0 and minus 1, 0. And show the numerator is never divisible by 3. Oh. So I wasn't wrong about the b minus a thing? TSTST had, this is TSTST with those 6 letters. No, it was in 2011, 2012, 2013. There were 3 days, and then in 2014, we suddenly lost all semblance of quality control, and so there were only 2 days because there were not enough problems. And then in 2018, we regained attempt at quality control. So there were 3 days again because we had enough problems. Yeah, no, it was literally like we just didn't have enough problems to run 3 days for a few years. Between like 2014 and like 2017. There was a period of time where the team selection in the US was sort of just like somehow get problems somehow, and we didn't actually get problems. If you take mod 3 or mod square root 3, how do you deal with the rotation matrix though? It is the identity. Seriously? Okay, well, let's write the rotation matrix down, shall we? Yeah, I think I believe you actually. So the idea is that the rotation matrix that's involved is M cos this is the rotation matrix. And so as before, okay, so the point is not that 0 and 1 are the same, like you're gonna say. The point is that the rotation matrix is the identity matrix. And so scrap that. So I'm confused. Why doesn't this work for... Why did r equals 3/4 fail? Because for r equals 3/4 we had a construction, but it looks like the rotation matrix should be the... No, it's not. What am I talking about? 3/4 is... Okay. You take p divides b minus a so that... Okay. And then the point is this is congruent to... So we say this is congruent to... This is a non-standard definition. We're going to say this is congruent to the... Define as congruent to Q mod P. And this respects addition and multiplication. So when I look at this matrix, root b squared minus a squared is... Wow, okay, wow. And then so this is 0, this is 0, this is 1, this is 1. So the rotation matrix only acts by the identity. Consequently, if I start with -1 and +1, you will never get... What? So the even denominators are not part of a Pythagorean triple. So I never have root b squared minus a squared being a rational number. Evan, can you give a summary of what has been done so far? Let me first collect my thoughts because I think we're almost done. What the heck? So, wow, we were right. The 1 minus r is really important. Wait, so does r equals 1/2 work? R equals 1/2 fails. Yeah, there's still that case. 2n minus 1 over 2n. But we apparently know that so r equals 1/2 doesn't work though. We know r equals 3/4 work. R equals 5/6 is apparently questionable. You can move by 2/3. Five, 6. No, you can move by 1/3. X circle is defined on the IMO. It's just when I write it up, I don't bother because, like, if you don't know what an X circle is, why are you trying the IMO 3GO? So why does 5/6 not work? So 5/6, the problem is you can only move by 1/3. I don't see an issue with that though. 5/6? So that doesn't work if I go there. If I go to 2r squared minus 1, 25 over 36, 25 over 18. So you can shift by plus minus 1/3, and you can shift by whatever this number is, 11/18. Can I get 1/2 by doing that? I think so, right? Because I can get 2/18, or no. Take mod root 11. But, like, why does 3/4 work and 5/6 not work is my question. Like, at 3/4 I take mod root 7. I agree you can take mod 11. Okay, actually, I agree with that. And in that case, it's reflection. But, like, 3/4 worked. Why shouldn't 5/6 work? Five, 6. Well, I got like plus minus 1/3, but I also got plus minus 11/18. So, the heck? Okay, if I have plus minus 11/18ths, then I can get plus minus 5/6. No, this should work. Right? Right? Am I an insane person? Plus minus 11/6. 11/6 and 1/3. Can I just not get half? No, this is fine. 11/6, so I can get then I can get 15/6 or yeah, I can get down to 3/6 by subtracting 4 copies of 4/3. Yeah, so this is fine. I can get 1/2, right? Right. Also, for Geico Lizard, I'm pretty sure... So I think what people are trying to tell you is I think the condition holds for every right triangle. Yeah. Just FYI. So I think it should be okay, right? I think nothing is wrong with 5/6. I think I can get to 1/2. If I look at this argument very carefully to make sure I didn't screw up a sign. So I can move the interval by 2r minus 1 in either direction. Is that right? I don't think you can get plus minus anymore. What do you mean you can't get plus minus? Like, the claim is if I have an interval 0, 1 on the real line, I can shift it by... No, I'm not looking at 0 and... I'm like saying if I have this interval 0, 1 here, like this yellow interval, then I can shift it in a direction. I can shift the whole interval. I'm not shifting like a single point. Oh shoot, are you serious? No. I just mirror the whole construction, right? Yeah, so I can shift the whole interval by plus minus a third. Why can't I shift it back? Am I crazy? Yeah, it's the whole interval. So like, yeah, if I'm moving a whole interval, I just nudge it, I think. Okay. No. I'm so confused about this. So, apparently the answer is only... The only ones that fail are these, and also like 2n minus 1 over 2n, which I guess is included in them. Or no, hang on. Okay, let me actually work through this for a general A over B. So if R equals A over B, then I can shift by plus minus A over B. Sorry, what am I talking about? 2n minus 1 over 2n is the ones that we think we can actually construct it. So I can shift by plus minus 2 over n. No, 1 over n. And I can shift by... So 1 minus r squared is 2n minus 1. And so twice that is plus minus 4n minus 2 over 2n. Okay, so 2n squared. 2n minus 1. These are the things I can shift by. And so if I am guessing correctly, this is going to be times... Let me write these in the same color for visual consistency. 2n minus 1 over 2n squared. This is 1 over n. This is 2n squared. So if I take n copies of this, this is 2n. I think I mismultiplied. I think I'm bad at arithmetic. This is 4, right? Not 2. And this one... Do I just do 4n? No, that's not correct. Oh, jeez. Three n minus 1. This one, this example is over 2. Wait, shoot, this assumes something about the parity, right? I mean, this is for n odd. For n... Really? That assumes a parity? But if R is like... So this is the n odd case. But if n is even, I don't care anyways. N even, easy. Okay, did we get it? Did we get it? Alright, did I make any mistakes? Oh my god. Wow, what a problem. Holy shoot. I think this should show the only answers are 1 minus 1 over even denominator. Okay, actually, I only did the plus case, but the minus case doesn't... What did you get? So for r greater than 0, I got the only answers are 2n minus 1 over 2n for n strictly greater than 1. I didn't do the minus case yet, but I think it should be symmetric. Yeah, if theta is a rational multiple of pi, then it doesn't work? Yeah, but that only happens 5 times. Proposer? I don't know who proposed this problem. They weren't very good about releasing problem authors around this time. Do I run into issues with PS2? I shouldn't. Well, odd denominators we handled anyways, so P is not 2. Because we assume B is even. Okay, I think I have to be a little more careful about the minus case. So the minus case should roll everything except minus 1 over 2n. Alright, same thing though. For r equals minus 1 over 2n, I can get two numbers. Those numbers are 4n plus minus 4n plus 1 over 2n. And whatever that freaking square whatever is. Four and 8. Hang on, I'm off by a factor of... Something's wrong. Something's wrong. I have an extra factor of 2 I'm not supposed to have. Shoot. Shoot. This is like 2 times 2 minus r squared. So this is not 11/18ths, is it? Even at 5, 6. Oh crap, this is 11/9ths. Maybe that's not... No, that's not good. That means I don't have use in denominators. Shoot. Freaking... Ah, no! This is 11/9ths. No! No! Oh, unfair! Are you freaking... Okay, we're not done. Let me go back to here. So when r equals 5, 6, I'm very upset. I'm gonna cry. So when r equals 5, 6, the problem is that even though I can get... I'm really confused. So for r equals 3/4, why does it not work if I take the everything mod 7? Then my rotation matrix is equivalent to just... Thank you, Leap Light, for the follow. It's equivalent to reflection, right? If I work mod 7 for 3/4? Oh, actually, it's not quite true that it's this matrix. You can also have the negation of this matrix always. Yeah, like there should be plus minus signs everywhere, actually. Rotating by r is same as rotating by minus r. So yeah, r and minus r should do the same thing. That's why it's something. Okay. I'm very confused. So for 3/4, why doesn't mod 7 do anything? The heck? What did I mess up? Thank you, HSAMS, for the follow. Oh no, what did I mess up? Okay, I'm gonna write these points explicitly so I can try to figure out what I screwed up. In the -1 +1 coordinate system. Is it because it's 2 times 1 minus r? No, 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 no. What is going on? Something about this argument with this matrix is strange. I believe there should be something stopping it, but it's not quite this. Because this one and 1/2 are not congruent modulo anything, like ever. So the matrix we were multiplying on is like for this special case. Something strange is going on. So we're multiplying by the matrix 3/4. 7/16. Or sorry, root 7/4. Is this the kind of problem courage is? Maybe. Can your live react to the new manhunt once we start games? What is the new manhunt? Also, are we ever gonna start games at the rate this problem is going? Is this courage? Yeah, I think this feels like a courage type problem. Thank you, Pizza Paisaran, for the follow. Yeah, I don't think this matrix mod P thing worked. Like... This is... Even denominators are really killing me. Like, these 2 points are congruent mod... oh no, this point is congruent to this point. Okay, wait, actually maybe this might explain what's going on. And then... So these guys are congruent, mod 7. And then... This point... So I guess we just get like -5 and -7, and like this point is like congruent to -7, 0 mod 7. So I don't see the obstruction. Like... Are we sure that, like, I'm not even sure that like 1/4 doesn't work anymore. Because it feels like for 1/4 you have to take. I guess for 1/4 you can take both mod 3 and mod 5. Does that do anything? But like. Oh, no, for 1/4 you can take mod 3, but you can still reflect. Like, the problem is -1/4. You have -1/4. Like, the rotation matrix isn't just through +r, it's through -r as well. So, you would need a mod for which, like, both 1/4 and -1/4 are 1, which doesn't exist. Yeah, so, okay, we have made a lot of negative progress. So, whoever was asking what to summarize what we've done so far, the only answer is that we've shown that odd denominators don't work by doing this. And we don't know what we're doing with even denominators. Yay! Is problem solving just let's try this and what? So problem solving involves a lot of like running around in a dark room with your arms flailing as you crash into things and slowly figure out where the things in the dark room are. Yes. Doesn't taking P? No, it doesn't work because the problem is that like there's two rotation matrices. The problem lets you rotate both clockwise and counterclockwise. So because of that, like in this argument here with the r and like you also have the -r cases. Like there's a case where this rotation matrix can also be through -r. And because of the -r, even if P divides B minus A, it does not follow that the rotation matrices are all clockwise rotation is corollary of the other one. Wait, what? No, you can do both clockwise and counterclockwise in the same problem. There's no -r? What do you? Oh, wait. Wait. Okay. Am I a crazy person? Oh, never mind. There's no -r. Never mind. You're fine. P divides B minus A is fine. I got worked up for nothing. Sorry, you're correct. It's just minus plus minus. Okay, so then this part is fine. Yeah, ignore everything I said for the last 10 minutes. We are somewhere, just not very far. Okay, so what's the deal with 3/4 again? 3/4 worked. Why does 5/6 we think not work? Well, we took mod 11. No, we just no mod 11. I'm so confused. Why is there a stream voice chat? So subscribers can pop in and say hi. I don't know. Yeah. I mean, I figure that the subs won't abuse it because if they do, then I just unsubscribe them, and then that actually costs them money. Hi, Brian.
Wait, can you hear me?
Yes, and so can the whole stream. So don't say anything stupid that you'll regret. 3/4. Okay, I'm so confused. So what's the obstruction with?
I still don't think this is a good idea.
One at a time, one at a time.
Hi.
Hi. I agree. There's a bit of delay. That was inevitable because Twitch has some delay. But I am muted on Discord, so at least you don't hear me twice. Just hear yourself twice. Okay, guys, help me figure out what's going on with 5-6. Like, I got 11 ninths. I don't want 11 ninths. I really want an even denominator, but I can't get any even denominators. So, like, what the heck? Like, for 3/4, it's fine. You can get an even denominator. But... The x and y coordinate both have v2 equals 0 or both equals -1. So I look at x minus y. That's not a bad idea. Okay, so for 2n minus 1 and 2n, man, what a disaster. Okay, so let's zoom into here. Then again, my rotation matrix is r root r squared minus 1 with a plus minus sign, minus plus this. Alright. And when I multiply this by... When I multiply this by any displacement vector, how do you show that? Like this V2 thing? Like... Is it still a V2 of the rational part? Because it feels weird to me because the irrational part also has... Like, okay, let's specialize the r equals 5-6 so I can see what's going on. I'm multiplying by things like 2, 0. Those are my displacement vectors. My claim is that I want the displacement vectors to all basically be not 36, what am I writing? 6. So the first displacement vector is 2, 0. And the result of that displacement is like 5/3. Thank you, data calculator, for the 50 bits. Right. So I think the sentiment is that, yeah, these are all denominators. So maybe I'm ready to claim that all points achieved starting from -1, 0 and 1, 0. have v2 of x, like, yeah, I claim that the x coordinates always have all denominators no matter what I do, and the y coordinates always have. Actually, I just claim all denominators always, right? What am I writing? Always all denominators. That doesn't help. 0 has a wait. No. v2x greater, strictly greater than 0 is what I need. Odd numerator and denominator for this one, and even numerator and denominator. Just, okay. Right, and the reason is that if I go from x1, y1 to x2, y2, I rotate, then the new pointer's coordinates, the new x coordinate is x2 minus x1, y2 minus y1. Here's my rotation matrix. Where I really should just say like I don't know. This is abuse. What I mean is the denominators of x plus y always odd. I bet I can get, it feels like x is odd and y is even though, right? Like I feel like I can say something even better. Do I really need x plus y always odd? Oh, you're correct. I need x. No, I don't. No, I don't. Okay, let's think this through. This is so much notation abuse. Do I want some? You might be right, actually. It might be some. Okay, I'm writing garbage. Oh, okay, I see. And then one of these is plus and the other is minus. So the new sum of coordinates is like oh, calculation is so hard. So the change I kind of want to say x rational part. No, you're probably right. I need x plus y. So is this actually true though? Yeah, I feel like we're really close, I think, but I can't get the ending. I can't get this x plus y always odd thing that's being claimed. I'm not sure it's true. It feels like some form of this statement should be true, but I can't see exactly what. I'm gonna look at 5-6 again. Maybe I can just claim the whole 4x4 table. I claim x rational part odd. I'm thinking about the hexagonal grid for r equals 1/2 actually. I know what it looks like basically explicitly, and it has this property, so I'm gonna hope that it works in general. So y rational part even. We'll just say all other parts even. How about that? Maybe that's clear. All three of them I claim are even. Then when I go to here, well, this is going to be like, the point is this is even plus even roots the whatever it is for both of these. And I believe that should be Is that true? No, that's not true. Because for the oh my god. Sorry, you're right, this is not true. What am I thinking? X plus y is what we want. Is that the desired claim? In which case, A plus B plus C plus D odd. Yeah, I know what you're going at. Is that true though? And if so, why can't I check it? Thank you, N05124 for the follow. Do we do math on this channel often? Yes, but not very well. I always have A plus B plus C plus D in. Is that so? I'm just supposed to expand, and you're telling me it'll work. All right, let's expand. So, rude. Right, so it's like 2n minus 1, 2n. This is one part, and the other contribution in mod 2 is and we're given that maybe not even, just v2 at least 0. No! If it's v2 at least 0, it doesn't rule out 0, 0. Right? Like here, when r equals 1/2, I can draw a picture of what all the points are, right? So if this is like it's like minus 1, 0. This is 1, 0. This is Jesus, how do you do geo? 0, root 3. Haha. So I mean, if you look at this picture, it sort of suggests what the claim should be. Thank you, Hammy Tao, for the sub. 4 months. Man, I feel like, yeah, we're still working on this. I feel like we've narrowed down to the set of R, which is either 2n minus 1 over 2n, or is minus 1... What's the other one? What, the negative of that? B minus... No, actually not the negative, just 2n minus 1 over 2n. There's no negative case. Thank you. When UCIMO results will be released, like by next week, probably. Like all the scores are, you should have gotten your scores back already for UCIMO. All I have to do is collate the results and then wait for anyone to appeal, which so far no one's done yet, thankfully. So then I post the report and then ask AOPS to send out an email saying, hey everyone, results are out. Have you had TSTST stream yet? Yeah, we had the day 1 stream a week or so ago. How long are appeals open for? They're closed, so I really just need to collate the results. Rep Sam, hello. We are dying on the edge case R equals 2n minus 1 over 2n. Any help would be greatly appreciated. We know it's possible if n is even, and we think it's probably not possible if n is odd, and I just can't get the last case. And I'm like very sad. What am I missing? What am I missing? Okay, is there a definition of even that doesn't, like, require me to separate the rational and irrational parts? Root 11 by 1. In other words, look at the ideal. That's high IQ. Alright, so mod the ideal root 4 minus 1, comma 2. Then what's the rotation matrix? It's like... Like, the thing is, the rotation matrix has a 2 in it. So, like, the rotation matrix has a denominator of 2. So I feel like things are just really bad. Correct me if I'm wrong. Like, what do I do with the... Which TSTST is this? 2013. United States. I want to straight 11. I'm like, even barring that, I feel like that's not the thing that I'm worried about. The thing I'm worried about is the fact there is a 2 in the denominator of the rotation matrix. So it means that, like, I don't know, what you can't divide by 0. Hi, Nuke. I love your streams, thanks. I am currently getting wrecked. I'm so sad. I thought we almost had it, but... There's like one last parity obstruction I need to weed out. Can't do it. Where are we on the SPUC? What does SPUC mean? Special unit circle? Jesus, it's been like 2.5 hours. It's like the entire duration. To be fair, 7 and 8 on this test were really easy, so I mean, you do actually get like a long time on this problem. But I can't get this one case, and it's so frustrating. I know I'm missing just something, and I don't know what it is. I guess the claim I want to it's not true that x plus y. Freaking. I could just write 4 variables out and then expand and see what happens. I really didn't want to, but I'm getting a little bit desperate. So it's like x2 rational plus x2 irrational root thing x1 rational plus... This is the worst notation I've ever made up. Expand. Okay, so what's the sum? What's this rational part work out to? Okay, so it's like 2n minus 1 over 2n times... Thank you, I have Vanth for the follow. You should be as calm as a lamb, Lamau. Do I look calm right now? I'm like ready to... I'm done here. Ah! Everything's so bad. This won't work. Okay, thank you, QQEAZ, for the 2-month Prime sub. Appreciate it. This is freaking awful. Like, okay, like, can I claim, like, the V2 is exactly something? Is that a thing I can try to do? That seems too strong. Like I claim that they have... What's the claim I need? I claim they all have all denominators, so they never have a denominator of 2. That part I think I can definitely say is okay. But then I need to also claim something about the parity, and that is a lot worse off. I can't get it. Like, if there's a factor of 2 and the division by 2 is also... Major props for trying this kind of thing? Thanks. It's actually a lot of fun, but also I just feel really stupid afterwards. Because I make lots of mistakes live. Oh man, I just can't get the last case. I don't know what I'm missing. I know that there should be some parity obstruction, but because there's a denominator of 2, I can't see what I'm supposed to do with it. Wait, maybe I shouldn't be... Maybe I should just add the things. Like, I'm looking at x plus y, right? Like, I can add them and then hope the 2 cancels off during the adding or something like that? Evan, moderate sketchy chinks links in chat. Okay. Wanna become famous? Wouldn't that be nice? But I wanted to become famous? Okay. Yeah, sorry, I don't know how to help you. Are we allowed to backseat solve? Yes, I've gotten a lot of help. I'd suggest to take famous angles and see what happens to 1 point. Like the 60 degree? I mean... Could I lower the volume of the music? Yeah. It's hard because right now the volume of the music of the volume was at 3% before your request. I changed it to 2%. We'll see if that helps. Yeah, I don't know why the dial goes so high. Like, like a new launch. How about 90? So if you have 90, you just have like a square lattice, right? That's also... So, so say where we are. I've like ruled out every value of r except like 2n minus 1 over 2n for odd n. Yeah, it's like we're down to this one really sticky case that I feel off by a factor of 2. Man, this was the day I got like 10 problem requests. And here we are. We're still on this one. Someone please finish this last case for me. Jesus. Zero solves day. How many solves live on this problem in contest? I don't know. I wasn't at MOP that year. I was just looking for data that satisfy everything but the midpoint part. Yeah. So theta 60, 90, 120 will work. However, Niven's theorem says that those are basically there's only a very small set of data for which theta is rational and cosine theta will still be rational. So the other values of r will not, like, for every value of r that isn't 0, 1, 1/2 and the negatives, the cosine will not be a rational multiple of theta, and so you want to describe it in terms of the cos theta instead. You need a tessellation pattern to have the rotation hold. It just means that the thing will be dense. So you weren't here, I guess you probably weren't here at the start when I, the very first thing we did was say that for all but a few values of r, the set of any good set will be dense in the plane. Like there will be, you'll have a lot of points exactly because the rotation angles won't be. Yeah. How far are you from solving this problem on a scale from 1 to 10? I think you never know until you, like, if you have a gap, you don't know how big the gap is. That's sort of, unless you see how to fix it. Like, if you see how to fix the gap, then fine. But, like, in a situation like this where, like, I have a case I haven't solved and I don't know how to do it, like, I don't know how. If I knew how big the gap was, then I probably also know how to fix it. I'll put it that way. Is 5/6 really not doable? 1/2 wasn't, so I have reason to believe that. It just seems so off. Okay, I'm gonna write out the other one because I'm running out of ideas. 2n minus 1 over 2n. Sorry, this is not the right notation. This is. So this is just the sum of the irrational parts. X2 irrational plus Y2 irrational part plus X1 irrational part minus. I mean, the signs don't really matter because I'm going to take everything. Oh, there's another term. 1 over 2n times wait, does everything just this bracket and that bracket wait. So this thing adds up to this thing and this goes away. And this and this add. No, there's got to be a flip sign somewhere. One of them should flip. There's a minus sign here. This will affect. So something's wrong. It's not supposed to add up this way. Be careful, be careful. So the real. Oh no, this part is fine. And this irrational part. This is minus. Minus plus. That was too good to be true. It is still kind of promising, because when I add these up, there's so much stuff. I see. When I add these up, I think the 2n at the bottom will kill off anyways. So it's like x2q minus x1q times. Man, so that's all I needed to do. Just add them up. And minus 1 over n. And then okay, wait, which one is negated? So that this minus sign causes these minus signs here, and it should cause minus signs somewhere else. On the rational part. Here and here. Sorry, this sign is flipped. This should be minus, this should be plus. But I can see something now because it looks like the four n squared minus 2n minus 2, 2n squared plus n minus 1 over 2n. Wrong color. I see. So by adding it up, even though I have a bunch of gross stuff all over the place, the denominators go away, which the denominator 2 that is blocking the whole solution finally disappears. And that will probably be all I need. Y2 irrational part minus Y1 irrational part. I really hope there was something that I could have done to not do this, but maybe it's fine. So what was my claim to begin with? The claim was that x plus y is has rational part odd and irrational part even. So in other words, actually that's not good. Maybe I should just say x plus y and the sum of the... Do I need something stronger than that? Yeah, I'm like, my point is I want to look at the sum of the rational and irrational parts for every number. The claim is that this number... I don't even care about... Do I care about the denominators? I don't really care, right? No, I have to make sure they never get a 2 in them. Which seems like it should be easy. That should be okay. Okay, let me write down a claim. I think this... We should almost be there. We should have... I'm such a scaredy cat. Won't expand. So x to the q, I definitely want in my hypothesis, all 4 numbers have all denominators. Also, there's some. Is odd, and that's dubious. Shoot, what's the claim? I expanded the whole thing out. Why won't it work? xq plus yq is odd. But then the minus signs screw everything up. Actually, maybe they don't, because I'm... Not two, they won't. Not two, they won't. Okay. Actually, just the sum is fine. No, actually, I need both one. Okay. But, for me to kill off the denominators, I really do need to add them all together. This is awful. I'm so annoyed. Okay, is my claim good enough? So if I add the rational parts, x1q and x2q subtract. Oh, fuck. Well, actually it's fine. We're taking mod 2, right? So when I add these numbers, no, it's not good. x2. This is awful. Like the sum does what I want because the 2's go away, and so my parity then I can take mod 2 and it's okay. The problem is I'm not 100% sure that none of the numbers introduced have denominators of 2 in them. So for that I need to actually look at every component. Because if anything has a fact like the denominator of 2, we're in trouble. And for that to be true, I need like x to the q. I need the second bullet in order to make that work. And if I need the second bullet, then Oh wait, no, it's fine. I'm adding the wrong ones. So for the second bullet, the ones that I need to add are this one and this. No, that's not legible. I need to add these two and check that they are a number and this two. And thankfully, this is the one for which they just add, right? Maybe. Jesus. So that's the cluster. So the first one's okay. It's the y's that I'm worried about. When I add the y things. This is such a headache. I'm so confused what I'm doing. I have no idea anymore. Yeah, I have no idea what I'm doing. This is a new record. Yeah, normally I cut it off way earlier than this, but I really felt like this last case I should just be able to do, and I can't do it. So I'm really sad. Like, there should be some parity obstruction. Have I been on this since we started? So like 3 hours. Like the last 2 hours I've been staring at this one case. I just can't figure it out. What's the case I miss? Like, what am I missing? This case doesn't work out. Like, I'm just frustrated. I'm like upset that this one case is like just not dying. Because I feel like I have almost every value of R, except for this one case. Like I can't get R equals 2n minus 1 over 2n for odd n. That's it. But like no matter what I'm trying, I'm gonna try doing the calculation again on paper to see if it helps, because sometimes it's harder for me when I try to do it on the tablet. Are we still on this? Yes. I mean, usually the problem is that because I've gotten so far, like I have all but one case, I really don't want to give up. But God, this... I'm so annoyed. Okay, well, I already found one calculation error. This is not 4n squared minus 1, it's just 4n. Minus 1 over 2n. This is plus 2n minus 1 over 2n. Okay. Yeah, it's 4n minus 1. That's a mistake. Did you start sleeping? Alright, so we think that... So we are left with this case. Like r equals 2n minus 1 over 2n is the only case that we haven't solved. We've proved that it works for all even n. We are unable to prove that it fails for odd n. Yeah, that's where we are. So I'm finally like, okay, I'm gonna take some paper and do this calculation neatly because the work on the board is incomprehensible. And see if I can prove the claims I want. So the claim is that for any point, if I decompose it into the rational and irrational parts, I always want the four numbers to have odd denominators, because if there's even denominators, we're totally screwed. The other claim is that I think I want the sums to be odd. So let me verify that claim now. adds, this adds. Well, if it's true that if that's really the case, then that will imply that x2q plus y2 irrational. That's not the claim I need. x2q xy. That's not the claim I need. If I want this to work, I need q plus I think. Or something like this. Like, I need some surrogate claim in order to make sure that the numbers that I get are actually integers. Because if they're not integers, we're in deep trouble. And I made a mistake in the calculation again. How many times am I going to screw this calculation? It's so confusing because there's like 8 variables and 8 parts, and they're all named like exactly the same thing. Anyways, these signs don't matter. As long as they're odd, we're okay. Because we know that the numbers have all denominators. But then they don't add up correctly. Wow, my calculation looks completely different from the... Oh, okay, I screwed up again. How many times am I going to mess this up? This is ridiculous. Okay, so is this one wrong as well? This is the square root. Yeah, this one's wrong as well. I flipped like everything. To Okay, so let me share my progress with the class. Or this dumb calculation. So I need some sort of claim, and here's what the matrix is if I believe it works out. So the delta matrix is so starting from these 2 points, if I do a rotation, then the explicit form of the delta of the next thing is given by the following. Okay. Maybe I should use a line. Let's use a line. That way the typesetting is correct. Oh, that's a new bear. Yes, this is also. But I really feel like there shouldn't. I feel like this should be easy, but no matter what I'll tell you, the last time this happened, I remember this feeling. This feeling happened to me when I was at the IMO in 2014 and problem 3. That was the last problem I had. And I could tell that I had something that if I did it correctly, it really should work. Like, it just felt right. Like, it was like, there's no way this doesn't work. But I just could not do the calculation correctly because I was so nervous. Because I was at the IMO. That's what happens when you do the IMO. And so I was just, for an hour, I just couldn't get it. I just kept doing the calculation over and over, and every time I made a different mistake. And it was just like, well, what is this? I'm gonna run out of time. So I was like, okay, this is stupid. And then I went to the restroom, cleared my head, and then I came back and then did it in 10 minutes. So what I'm saying is I'm like pretty confident in this method. Not like 100%, but I really feel like this should work. Like, it seems obscene to me that this would not work. But I just can't do the calculation correctly. Too adequately integral. Okay, thanks for confirming my thoughts. Alright, cool. So I don't know what that word means, but it sounds big. So, kabam. Cool. So we need some claims, and the claims are that x to the q plus minus y to the I is odd, and then x to the I plus minus y to the q is odd. And first of all, that will imply the odd denominators. So for odd denominators to work, these are well-defined things. And this guy plus this guy is odd. Wait, no. Hang on. Okay, what's the claim I want? So earlier we saw -1 and 0. Yeah, it's fine. So these numerators we don't really care about for the time being if we're just trying to show that each of the parts is... Our goal is to show that all the brackets are even and also like the sum of the stuff is even. So these parts don't matter, and we take the -1 over 2n, and that gives us x2q plus y2i. So that's an odd number and then an odd number. So the 2 will cancel and we'll indeed get an odd denominator number here. The same thing is true here. X to the I, y2q, x1i, y1q. Again, we don't care about these for the time being. Okay, so that's fine. So that proves the first part of the induction. The part that I need to carry through is I need this guy plus this guy to be an even number. So these two add, I get 2n minus 2 over 2n, so it's like n minus 1 over n. N is odd, so this vanishes. Here, I get 6n minus 2 over 2n, so like 3n minus 1 over n? The heck? So why is it 3n minus 1 over 2? Oh, actually, 3n minus 1 over 2n is fine, because that's also even. So this will resolve to an even number, so we're good. Similarly here, the 2n and this guy add up. It gets negative 2n minus 2 over 2n, which is n minus 1 over n minus. That's an even denominator, so this is even. And then this thing, when I add it, well, this is actually exactly n times... Hang on. This is minus 4n, so minus 4n plus 1, minus n. So this guy is odd. This one's odd. So the sum is even. And okay, honestly, if this doesn't work, I don't even care at this point. We're done! Alright, see you Electron DX. Hope you had fun. All of past streams are on YouTube if you ever want to see them. We stream every Friday night. Yeah. Okay. Yeah, because I was like, this has to work, because it's a parity obstruction, and you should just be able to say what it is. And it does. The problem is that apparently I can't do this calculation correctly, because this thing is disgusting. But it's true. And thanks for Bardagian for saying two-adequately integral. I don't know what that means, but it sounds like the correct words based on what I know.